We will introduce surgical protocol of Inno implant system. Easy, simple, fast access. Roll of drills in each part of drills. Drilling sequence. How to control the initial stability. Inno implant system surgical kit is composed of point drill, initial drill, final drill, countersink drill, and fixture driver. Inno system has 3 steps of total steps in diameter 4 mm fixture. The others have minimal 6 total steps. Inno system shorten the drill steps due to the customized drill and mount-free fixture. The roll of drill and its parts of the point drill, initial drill, and final drill will be described. Point drill has the 2 mm diameter triangular cutter and the index line of 7.5 mm step. To avoid slipping of drill tip, the point drill is started at perpendicular orientation on sloped surface and rearranged to the path of fixture in drilling mode. Point drill is positioned in the site to be maintained minimally the 1.5 mm gap between tooth and implant, and the 3.0 mm gap between implant and adjacent implant in mesiodistal orientation, the 2.0 mm gap between implant and buccal-palatal wall in buccolingual orientation. Initial drill is composed of 8, 10, 12, 14 mm in length. In the shank of drill, the length of drill is marked as the color as like yellow, red, blue, and green. Initial drill is composed of 2.2 mm pet cutter, 3.3 and 2.8 pilot cutter, 4.9 Crestal cutter and stopper. The portion of 2.2 mm pet cutter decides the direction of fixture. The portion of 3.3 and 2.8 pilot cutter guides the orientation of final drill. The portion of 4.9 Crestal cutter flattens the sharp and sloped ridge. And the stopper has the 4-way irrigation groups for cooling heat during drill preparation. Final drill is composed of 3.5, 4, 4.5, 5, 6 mm fixtures final drills according to diameter, and 8, 10, 12, 14 mm fixtures final drills in length. In the shank of drill, the 4.0 mm width and the 10 mm length final drill is marked as 4.0 by 10. Without countersink drill's preparation in the dense bone, the diameter 4 mm fixture might be placed by over 80 Nm torque force, and the diameter 5 mm fixture might be inserted by about 150 Nm torque force. It is reported that the high compressive placement of fixtures could induce the failure of osseointegration due to the surrounding bone's necrosis. For prevention of compressive bone necrosis, the gap between fixture and osteotomy hole has to be enlarged by countersink drill osteotomy. Fixture drivers are mainly composed of elastic spring component and hexagonal fixture engagement portion, which retain and rotate the fixture. The fixture drivers are two kinds of engine driver and ratchet driver. Engine driver has the torque tolerance limit of 50 Nm, and ratchet driver has 120 Nm limit. According to length, there are short and long fixture drivers. The depth indicator in shank is marked from 1 mm to 4 mm for measuring the thickness of soft tissue and depth of fixture placement from marginal bone. Drill sequence is simple and minimized. The sequence of diameter 3.5, 4, and 4.5 mm fixtures is a series of point drill, initial drill, and final drill. The sequence of 5 diameter fixtures is a series of point drill, initial drill, diameter 4 mm final drill, and diameter 5 final drill. Diameter 6 mm fixtures is recommended in replacement of the failure of diameter 5 fixture. The edentulous ridge adjacent of tooth is sometimes sloped. For completely submerged placement of fixture, the sloped ridge has to be flattened with Crestal cutter of initial drill, or to be used with longer drills than fixture's length. How to control the initial stability? 0.5 mm deeper placement. Pumping action of drill. Wide extraction socket. Weak bone quality 4. Dense cortical bone. The gap between drill's diameter and fixture's diameter is a major factor in fixture's placement stability and bone healing. The narrower gap makes the higher stability of fixture. The narrower gap induces the more compressive bone necrosis in dense bone. Inno implant system maintains from 0.05 to 0.1 mm gap in whole surface to prevent compressive bone necrosis and increase fixture stability. The 0.5 mm deeper placement of fixture in the stepped drill hole decreases the gap and increases the initial torque force of fixture. In the test bone blocks of various densities, the 0.5 mm deeper placement increases 10 Nm torque force in the dense D1 block, 9 Nm in the medium D2 block, and 4 Nm in the soaked D3 block. The bone chip in the gap increases the fixture placement torque. The pumping action of drill removes the bone chip in the hole. In dense bone, this debridement action decreases the high placement torque force. In soaked bone, no debridement action is recommended for high placement torque force. In test bone blocks of various densities, no debridement action increases 15 Nm torque force in the dense D1 block, 5 Nm in the medium D2 block, and 4 Nm in the soaked D3 block. In the wide extraction socket, it is difficult for the implant to be fixed in the sponge bone due to the absence of the cortical bone. For the firm fixation of fixture, the final drill could be narrower diameter than the fixture's diameter. In dense residual bone, the final drill of fixture could be used. In weak bone quality 4 and maxillary tuberosity, no pumping action of drill, and the 0.5 mm deeper placement of fixture, and the wider fixture than final drill's diameter are recommended. In the 4 mm diameter fixture's final drill hole, the 5 mm diameter fixture's placement increases more torque force than the 4.5 diameter fixture's placement. In dense bone of mandible, high compressive placement of fixture over 45 Nm could induce the marginal bone loss. Countersink drill is recommended in the sharp edge for prevent a marginal bone loss. During healing period, the compressed marginal bone is rapidly lost in no uses of countersink drill.